Are you energized by mitochondria? I am. Let's do the Bellringer.
All right.
Hey now.
Mr. Kovacs Class. It's Mr. Kovacs Class.
You might learn a ton.
It's Mr. Kovacs Class.
It's interesting too.
It's Mr. Kovacs Class.
And he's super cool.
It's Mr. Kovacs Class.
There it is, the mitochondrion, the powerhouse of the cell. Mitochondrion is singular. Of course, plural it would be. Good, you've been paying attention. Yeah, we've been studying the mitochondria and its ability to provide energy as the powerhouse for the cell. And some important things that we are trying to learn is there's a three-step process for how mitochondria take food that you eat and turn it into usable cellular energy. Now the key to all this, of course, is this molecule, right? This big molecule here that it's got adenosine triphosphate, or ATP. And I think we mentioned yesterday in class that the key, where the energy is right here in this little, this bond here between, there's three phosphates. When your cells break that third phosphate, there's energy released to do cellular processes. So ATP is the energy currency of cells, but we have to be a little bit careful because ATP itself is not energy. ATP is more like a storage or a battery that stores energy, right? And so the cool thing about ATP, even though it's like a battery, it's a rechargeable battery. And so the job of the mitochondria is to recharge your batteries. Simple as that. Recharging the batteries happens through cellular respiration, which is a three-step process. Although you could stop after each step, but you really want to get to the third step. The first step is called, well, you told me, what's the first step called? Good. Yeah, glycolysis. It's where you take glucose and you break it into pyruvate. When you do that in the cytoplasm of the cell, then those pyruvates move into the mitochondrion, into the intercellular matrix of the mitochondria, where the Krebs cycle happens. Step 2. Okay? And then we move to the membrane of the mitochondrion. This is where the ETC, electron transport chain takes place. And you see every step of the way, the 3 steps, ATP is made. You make 2 after step 1. You get 2 more, so 4 total after step 2. And then, holy cow, step 3 is where all the money's at. Of course, step 3 is, you need oxygen to do step 3. So we call this part of it oxidative phosphorylation or aerobic respiration. You can do just steps 1 and 2. Don't get that much ATP, but you can do them without oxygen. But if you really want a lot of ATP, you want to go step 3. That's why the mitochondrion is so important to cells. I mean, that's why you want to keep them around. Without them, you can make 2 or 4 ATPs. With them, you can make 38 ATPs. Wow. So let's power up today for today's class. Don't forget there's a book talk today, right? And Ed Puzzle, book talk, this Bellringer. Sounds good.